Right, okay, this first question then. Weird, they written it as a fraction, so, and they put really fat minus sign. I don't know why they put that in bold, but they have. Right, so it says, right, minus 2 and 5/8 as a floating point, key bits, 6-bit mantissa, 4-bit exponent, and they have told us it's both in 2's complement. Okay, so our first thing whenever we've got deanery is to say to ourselves, right, let's just do it as a fixed point value. So we're just going to put a binary point. We need to make sure that we can't write minus 2 and 5/8, so we're going to write 2 and 5/8. But we need to make sure that we have enough binary positions so we can put a positive number down. So I'm just going to write that down so I can put, my first thing that I'm going to put in is my sign bit. So I'm saying it's a positive number, it's positive 2, but I've got to get 5/8. So you've got to do a little bit of maths. So that's a half, a quarter, go down to the eighths. So 5/8 is a half and an eighth. Okay, so that's my starting point. What I then need to work out, I need to normalize this. Okay, so I need to move that binary point. And remember, normalization means we only keep one copy of the sign bit. So if we look from this direction, we know it's a positive number. There's the sign bit, but there's another sign bit. So that first one we don't need. So we want to put our binary point there. It's currently here. Now this is the bit where you've got to be careful. So yeah, we show that we move it. So we go 1, 2, but please put an arrowhead on so we know which way it's gone, because I've actually now got on my diagram 2 binary points. So it could be confusing. Okay, so I've done that. So my first job is to now write the exponent is 2. Now, is it negative 2? And a few people were getting this messed up. They were just making it a negative. If we started with a number that was bigger than 1, when we normalise it, we're going to be making it smaller. So the exponent is what makes it back to the original number. So the exponent, to make it larger, would be positive. Yeah? So if the number was a quarter, when we normalise that, we're going to be making it bigger. So that would be a negative exponent. Okay? However you want to think of that, I don't mind. If I had to move the binary point to the left, it's a positive exponent. If I move it to the right, it's a negative exponent. As soon as I've got that, I can do that bit of the question. So even if I screw up the mantissa, I'm going to get something for the exponent. But I've written exponent plus 2. It said 4 bits. So that would make the exponent 0, 0, 1, 0. Plus 2. Yeah? Right, let's sort out the mantissa. We've only got 6 bits. So we've discarded that one because we normalised. So we only want the 1 in front. I can put the binary point in. I don't have to, but I'm going to put it for my own sanity. So that's 1. And then I've got to be careful. So I've got 0. I've got a 1. A 0. And a 1. Now, after you've written your number down, just double check you've got enough bits. Because there was a few people messed a further question up where it said so many bits and they writ 7 when I think it was supposed to be 8. So I'm just going to count up. 1, 2, 3, 4, 5, 6. That's 6 bits. I'm not just going to leave a binary thing there. I'm going to write mantissa. So they know where the answer is. And I'm probably going to underline it or something. And that's my answer. Yeah?
You're doing minus 2 and 5/8.
Pardon?
That's not a minus. You meant to flip it.
What's not a minus?
You've just got positive 2 and 5/8. It's meant to be minus.
Oh, I've completely...
So you got it wrong.
Well, I've got it wrong. Right, so how do I fix it?
You can do it from there still.
I can do it from there still.
Yeah.
So this is normalised 2 and 5/8. Right, but I want 2's complement. So I just 2's complement this. So let's say we're doing 2c. So you can do it. It doesn't matter if you do this complement at the start or the end. It doesn't really matter. The exponent doesn't change. The exponent is what the exponent is. Right, so remember when we do 2's complement, flip, until you get to that last one, and then leave that last one. So we're going to flip. Well, that's good because that shows it's negative. I'm going to put my little point in. Then I'm going to flip, 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 flip. That's the last one, so don't flip it. So that's my minus 2.5 and an eighth normalized. Yeah, it doesn't matter if you could actually, as soon as you get to this bit, you could do the flip. As soon as you've written it down, you could flip it. It doesn't actually matter. Okay? But it's important that you annotate what you're doing. When I double check that at the end of the test, when I've got a bit of time, I would have gone back and gone, hang on a minute, I've got a positive number there. That would have been my check to myself. Have I got the right sign for that number? Okay? It is easy because there's a load of steps. So like, miss a step, or forget a step, or just plough on. Okay? Which you can, on some of your answers, you can see that that's what you've done. The bit that I found a lot of people did on quite a few of the questions, they automatically were flipping the exponent. So a lot of people kept writing negative exponents, even though it was a positive one. It's that thing with two's complement. Because it's got the word there, doesn't mean you have to complement. You only complement when you're dealing with negatives. If it's a positive value, it's just the same as sign of magnitude, remember. Write down your sign bit, write down the value. Okay, let's start.